Good evening, everyone. My name is Tony. I choose this structure as my video project structure. I choose this structure because it's near the building site. I can easy to find it, and then it's located in the Swanson Street. I choose this structure as my video project because it's funny, because I want to know how much capacity he can get for for the actual force. So and I want to test if the people stand here or live here is safety or not. So I choose this structure, and this structure is near to the KFC. So and near our school. So I choose this structure as my video project stuff. After I went home and I decided to finish the video project because I already choose the structures. So next I will do the video project 2. So here is my video project 2. So from the tables we can see that this one is my structure, and here is the beam, because this one is a cylinder. So after I discuss with the three, we don't need to calculate for the cylinder, so only focus on the beam. And this one is the shapes of the beam from three sizes. And then next, and then I put, because we have to put the force, which is the last number of our ID numbers, student ID numbers. So my last number is 7. So I put 7 kilonewton per meters to give the extra force on the beam. And then because my structure is symmetrical, so I put this one is equal. So first we have to calculate for the moment of inertia, which we learned from lecture 2 and then lecture 1 and lecture 2. We have to got the centroid and the moment of inertia. After that, we have to focus on the beam, which is lecture 7 and lecture 4 stuffs. So we have to calculate for the force on different beams and find the moment and find the force on each side, because this one is symmetrical, so this two is the same. And then let's move to shear force diagram and the bending moment diagram. Because from my bendings, I make this one as x1 and then here is x2. Because this one is all covered 8, so only xy is okay. So from this one, I can get the shear force bending diagram, and this one is the bending moment diagram, the bending moment function, and then I can got the two function here. And then the first one is from 0 to 3.5. So just put a number in and then get a straight line, because it's the uniform structure. And here, because it's the uniform, and this one is the quadratic function, so it is the curve, so it has the highest point. Because in here the shear force is 0 in this point, so the bending moment must be the maximum, because shear force is the maximum and the bending moment should be the lowest. And then from that we can get the formula and get the pressure. After that, 3 ASCII require us to calculate for the stress in each point. So I choose the quarter point on this line, and I choose the middle point and the original point to compare these two graphs. And after I calculate, I can got this one, and then move to the let's move to the shear force. So from the shear force we can know that the tau, this is the formula which we have to which we learned in the lecture 3 or lecture 5 or lecture 6. So first we have to calculate for the centroid, the moment of inertia, because this one is the square, so the centroid is the middle. And then next we have to do the deflection of the beam, and then to calculate for this graph, because my graph is symmetrical, so I put into the 1.75 and then to put the x equal to 0 and 1.75 and get the cy and the c2. After that, this is the summary of the results. So from this one we can see that Vmax is 4.5 times 10 negative 12 millimeters, which means in the middle point is the maximum, the V maximum, the fraction maximum. So next we have to move to the summary part. Here's the summary part. 3 didn't ask me to get a summary, but I make it clear. And then here is the stress transformation. So first we have to get the sigma x and the sigma y. After that we have to calculate for the theta, the angles. And then after we get the angles, I find an interesting thing is, because I learned not clearly before, but after that when I ask a teacher for help, and I get the sigma p2 and the sigma p1 always has the 90-degree difference, and then the sigma s and the sigma p2 always has 45 degrees difference. You can see that 135 minus 90 equal to 45, right? 45 degree minus 0 is a 45. So I can get some summary from here. And after that we have to calculate for the tau max, which means we have to use this formula and then just put number in and get a formula. For this one we have to calculate 3 times, because we choose three points, as I said before in this graph, this 3 points, and then put the number in, because I get some summary here and then just put number in. It's okay. And the last one is here. We have to compare with the last one's here. We have to calculate to compare my maximum to compare with the to compare with total capacity to check its success or failure. So after I compare 3 times, my structure was safe, so that I can learn, I can get some information that my structure is safe, not a failure. So next, I will show my works for my whole video project. So from in my opinion, from this video project 1 to 3, I can learn a lot of things. Not only just focus on the calculation part, but also I can learn. I can learn how to check the structure if it's safe or not, and then from this video project, not only lectures or mentors give me a lot of help, but also my friend gave me a lot of friend of help because we cohesion each other and then help each other. I think group power is more than individually. And after that I can learn just like because I first learned this one is in the statics, but this semester is all together. It's just like a condensation, make them cohesion, and then I can learn a lot from this one. And not only to on the one hand I can do the revision, on the other hand I can learn more new stuffs. So this is my opinion, and then I learn a lot from these videos project, learn a lot from these semesters. So thanks my mentors and lectures.